Hello everyone, welcome to lecture series on computer vision, and for today's discussion we will learn about the characteristics of a camera. In the prior lectures of mine, I have discussed the operation of a human eye as well as the camera eye. The main objective of a camera is imaging. So what is this imaging? Imaging is nothing but here we do have images which are the 2D projections of the real world scene, where we'll be knowing about the complex 3D to 2D transformation relationships, as well as we are getting to know where does a point x comma y comma z in the real world will be getting imaged. So obviously we know that in the image plane we do have the image itself is nothing but it is accumulating a many number of pixels, right? So the image I of x comma y measures how much light is captured at pixel x comma y, which is giving ultimately the intensity or the brightness at that point or at that pixel, which is nothing but the amount of light received by that point in the 3D world of the object, right? So anyhow you are having a good awareness on the operation of camera as well as the components of camera. So let me recap quickly what are all the things we have studied earlier. So a camera is mimicking a human eye. That means a camera is having the lens that is mimicking a cornea of our human eye, and a camera is possessing an aperture which is nothing but a pupil in our human eye, and the aperture is can be increased or decreased by using the diaphragm. Okay, so here you can see, right, you will be having in the camera diaphragm, and in the middle you will be having somewhere here like aperture. So the amount of light that falls on the retina of our human eye determining us the size of the pupil. Like large people will let us more light to fall on the retina, and similarly in the case of camera what happens, the larger aperture of lens will let us more light to enter into the camera sensors, right? So in the case of human eye, the iris will be controlling the pupil. But in the case of camera what happens? The diaphragm plate will be controlling the size of the aperture here. So just for a recap purpose, I have recollected all the things. Now the camera will be having, of course, the so and so elements. This will be my image plane, and this is my camera box, the enclosure I may be calling it as, and the front part you will be having an aperture, and we do also have here the lens of a camera in front of it. So this will be my optical axis, some 3D object in my environment, and if I assume from here to here, that means the distance between the image plane to this center point is nothing but the focal length. So all these elements are playing a crucial role in understanding the characteristics of a camera. So what is this depth of the field? So depth of the field is nothing but here it is the range of what is in focus to our shot. Like if we take the camera, what we do, we take the shots, we capture something, some environment or whatever the thing that we like, we do capture them. Now during the time of capture, so depend what is this depth of the field. So here you can see, right, here I am having wider depth of the field, we call this one as wider region. So here it is a narrow or smaller depth of the field. So in the case of the wider depth of the field, we can see everything clearly in one shot. So I have captured this scene, so I can see everything a bit clear, right? But in the case of my smaller depth of the field, I cannot see everything clearly, only few things getting focused clearly. That means the flower or the front leaves only getting focused clearly. That means a clear representation of pixels are present here. So coming to a brief about this depth of the field. So in the first case, aperture is wide, you can see, because this aperture is there, right? This aperture is wide. Okay, that means only this small length of the object. Okay, that means it is the object right here. This is only properly focused because of this lesser depth of the field. Only a small portion of the object is focused properly, but the rest portion is not properly focused in this scene. So that the portion we get, that means this only a small portion will be getting here a sharp image. Okay, and remaining in the scene I am getting a blurred image or blurred background. Okay, in the second case, if you observe, means I am having my aperture is very narrow, okay, or smaller. That means I am having here a wider range which is making me to properly focus the things which are present either in the background or in the foreground. So I am getting here a clear cut of information. That means, can I say now that aperture size is affecting, that means this aperture size is affecting my depth of the field. So because of this depth of the field, I will be getting a blurred image or I may get a clear cut image. Okay, so what is happening clearly here? Let me see. Now the depth of the field is dependent on three parameters. One will be the aperture of the camera and distance to subject, like whatever the thing we are capturing, and the focal length of the camera. So as I have said you, right, the depth of the, if I am having the larger depth of the field, I can see everything in one shot clearly. If I am having a smaller depth of the field, I can see only few things getting focused there. So depth of the field and aperture size are inversely related. How they are inversely related, let me see now. Right. Okay, so for this one, what I am going to take here in the next slide, you can see basically in a photography an aperture is expressed in f numbers, because in all the images you are seeing f, right? So aperture is expressed mainly by f numbers or f stops, we call it as. So this f stop is inversely proportional to the aperture size. That means if f 1.8 is there and f22 is there, for f22 the aperture size will be very low. For f 1.8 the aperture size is very wider or bigger. So this aperture is having a direct impact on the depth of the field. Like this is the way. This aperture is having the impact on depth of the field. As you can see here, the f1.8 will isolate either a background or foreground objects and make things blurry, because it is isolating the foreground and making the background blurry. You can see here in f1.8 image. But coming to f22 image, it brings all the foreground as well as the background objects into the focus. That means where I can able to see clearly. So keeping it all aside, I tell you a few general points that are we need to know the specification of a lens. So where that means here we have to consider the aperture, maximum aperture or the minimum aperture. If we are considering the maximum aperture, means we also have to know about its lowest f number. That means why? Because the aperture size as well as the f number are inversely related, as I have already said you. That means whenever we are going to know about the specification of lens, we have to consider the max aperture as well as the min aperture. Whenever we are considering the max aperture, lowest f numbers, it indirectly mean, and minimum aperture means we need to also consider the maximum f number here. So the max aperture of lens of course is also important. Why? Because as you said you right, as I have said you, if it is a max aperture means this one f1.8 where we are getting a blurred. Keeping this one aside, okay, the max aperture is also having some advantages in some areas. So where the max aperture of a lens is important than the min aperture as it shows the speed of the lens. Okay, by using the max aperture parameter itself, we can know the speed of a lens of a camera. Now, let us consider these two cases, that is f1.8, f22. So, you can see here f22 is giving a clear cut out image and f1.8 is isolating and hiding some information. So, keeping these things, f1.4 generally, because in this figure I hadn't depicted, but generally f1.4 and f2.8 are considered as fastest lenses. Why? Because they can pass more light into the camera. Because if they are passing more light into the camera means what happens here? Bigger aperture only, right? So then what is the usage? What is the application of passing more light into the camera? Because during the time of night photography it is highly helpful. Okay, and also these f1.4 as well as the f2.8, why they are considered as a fastest lens means they will be having the faster shutter speed, because you have seen the shutter here, right? And I have also explained you what is the main principle of the shutter in the camera operation. So f1.4 and f2.8 is considered as the fastest lens and they are having the faster shutter speed, right? Okay, now let me go with the remaining distance to subject. What is this distance to subject? So in the image, left side as well as the right side, if the distance, this is my camera, this is my subject, and this is my camera, this is my subject. If the distance to subject is closer, I will be having the shallow or the less depth of field. So if I am having less depth of field means no clear data pixel. And if distance to subject is far, so distance to subject is far, that means I will be having my wider DOF, that means wider depth of field, I will be having a bit more clear pixels. Okay, now the last one is focal length. So what is this focal length? Focal length is nothing but distance from this point to this point. Okay, so focal length I have given here. So as focal length gets smaller, image becomes more wide angle, more world points projected onto the finite image plane. So here larger focal length, smaller focal length from here, this point to image plane, you can see here from this point to image plane, if you see means what happens, image becomes more wide angle, more world points project on the finite image plane. That means everything I can see here. So if f gets larger, as because f1, now f2, now f3 is the larger here. So f3 is the larger means image becomes more telescopic and smaller part of the world projects onto the finite image plane. So only smaller part of the world will be projecting here. So for example, you can take here the larger f lens, that is of 100 mm, you see how the image is appearing, and if it is smaller, how the image is appearing. So for smaller f, that is of 16 mm, image becomes more wide angle, so it is a wide angle. For small f, here what is happening, image becomes less wide angle. That means it is a narrow angle where a small part of the world projects into the image plane. So this is the concept of field of view with focal length. So anyhow, this field of view and focal length are inversely related. So this is about the dependency of the depth of the field on the three parameters, that is aperture size, distance to subject, as well as the field of view. So during the formation of an image on the image plane, there will be a process known as image formation process. So what is exactly the image formation process here? We know that basically the sensors in the camera can convert the light photon into electrical signals. If this I consider as an image plane, I may get blurred image of this object, because why? Intersection of all the reflected light rays from the object. So light rays are hitting this object at this point, this point, this point, everywhere it is hitting the object. There will be a high intersection of all the reflected light rays from the object. I may not have the fine quality of the image. Because of this one, what I will be doing here a small adjustment such that the setup is designed in such a way that this is the one where I add here a barrier. This one is a barrier to block most of the rays hitting or reaching this film, right? In the barrier I am keeping only a small opening will be present in this barrier, and this opening is nothing but your aperture itself. So what happens finally? The aperture, because of this setup, blurring can be reduced on this image plane. So this is the concept of your aperture. A bigger aperture where we may not get the foreground and the background clearly. That means something will be getting isolated. Okay. So, and whenever we are narrowing the aperture size, means we are getting the foreground as well as the background information a bit clearly, right? We can't make my aperture as small as possible, as it leads to very less light to get through. Ultimately it results in diffraction, which comes into the play. So I should have to maintain the constraint with aperture size also. So this is the image formation. In the next class we will discuss about the geometric camera models. Thank you. Have a nice day.